The second most common topic area on the SAT is going to be Algebra 2 concepts, focusing mostly on nonlinear functions, with quadratic functions being the main one, and then exponential functions being the next main one, and then some other things that are just random polynomials and that follow rules for polynomials. But quadratics and the exponential functions would be the next type of problem that you're going to see. And then it'll be from function notation as well as, and then also systems of equations that have nonlinear equations in them. Okay? And so those would be the main topics, also working with the expressions like you'll see here in a moment. All right, so the first thing that we're going to look at here are what they refer to as the equivalent expressions, and that's just their way of saying if you have an expanded form versus a factored form, you'd be able to work between the different forms. It's also kind of when they're adding, subtracting, doing basic operations to polynomials. And so again, we'll stick with our sort of theme of doing the odd problems here. So I want you to try this problem on the bottom. Should be pretty straightforward. This should be, again, it's a straightforward question if you understand kind of what you're looking for. Basically what you're doing is you're taking this given expression and it shows that you're removing a common factor. You don't even really need to find everything, right? All you need to know is what is the R value, the R being the numerical coefficient part of that factor removed. And so if you look at 33 and negative 15 and see what would you take out of 33 to be left with 11. And again, pretty straightforward. You take out the 3, that's what your R is equal to. Now, if you're taking that 3 out, you're left with 11. Why? Again, you're taking out the 3, and from the y's, you're taking out 4 of them. But again, this doesn't necessarily have a role in the problem if you understand what the R is asking for. But if you took out a 3 y to the 4th from each term, you're left with an 11y for the first term, a negative 5 for the second. So this fits that pattern, and you just match it up. Okay, even though this is a straightforward problem, I just want to talk through, again, TID9s are still allowed on the SAT. Okay, so I would have it out with you. These types of problems, the Desmos doesn't do factoring necessarily. Okay, and so if you wanted to see what were the factored forms of this, if you look at the top line of tabs on your TID9, you want it to say the F2 algebra tab. If you don't have F2 as an algebra tab, it probably means you've somehow toggled into the custom tabs menu. So if you hit second home, that toggles back and forth between custom tabs and just the normal tab. So toggle from second home until you get that F2 algebra tab. That's probably, if you are going to use this on the SAT, all of your commands are going to be, or most of the commands will be located right there. So if you type F2 here, you're just looking to factor, and you can type your expression exactly as it appears, 33y to the 5th. The power symbol is this caret symbol right here on the far right. And then minus 15y to the 4th. Again, if there's any problems that are more complicated, you can factor it just by typing that expression in, closing the parentheses, and when you do, it gives you your factored form.
Yep. So we're going to have this on the test?
You can. Take it, yeah. ACT does not allow the TID9. The ACT, you have to have a more basic form, but SAT allows this. All right, if we continue working with these, just again what they would refer to as equivalent expressions, I want you to try question 39 here. So again, a lot of the stuff that we've done on Desmos, you can do on the TID9. So if you are comfortable with the TID9, definitely use it. It'll be to your advantage. But as far as these types of problems here that we're looking at, dealing with powers especially, and expanding and factoring, are a lot more easily done with your calculator. And so if I was given this problem, and I'm going to show you both, I'm going to show you how to do it by hand as well, but if I'm given this problem, I'm always going to be looking for the easiest or most efficient way to answer it. And so for something like this, all you're being asked to do is expand it from this factored form into this polynomial form. And so in this F2 algebra tab, there is a command called expand. It's option 3. So if you choose option 3, and then you do need to set a new set of parentheses inside, right? Because you're going to enclose this entire set of factors. So parentheses 1/3. So 1/3x plus 5/3. Close that off. I multiply by 5/3 x plus 1/3. I close off the factor, and now I have to close a second parentheses here to close off the expand command. Once I do this, the calculator will expand this for me. It'll give me the polynomial form, and so I see it right here. The question is asking, what is your b value? Well, the b value is the coefficient of your first degree term, and we see that right here, 26/9 x. So the answer would be 26/9. Okay, so again, I would do it the easiest way I could possibly do it. If you want to do this by hand, or if you have time and you can come back and check answers, and there's questions that you want to check, always try to check them using a different method than what you used to solve, if that's possible. So if you have time and you can check this, all we're doing here is foiling. So if we take the product of the first, okay, it's just a matter of working with fractions on that. So multiply across the top. 1 times 5 is 5. 3 times 3 is 9 across the bottom. X times x is x squared. So here's my product of the first terms. Move to my outer terms. So 1/3 times 1/3 is 1. 1 times 1 is 9, or 1. 3 times 3 is 9. And x times just itself. So 1/9 x. Then we move to the inner products. Here we have, again, the result will be a first degree term, so I'm going to vertically stack it under this other first degree term. So 5 times 5 is 25, 3 times 3 is 9, so I get 25/9 with the x carried along. And then the last term, which again we don't really need, but 5 times 1 is 5, 3 times 3 is 9. And so here is our total combined expanded form. And if I just add straight down the columns, I get 5/9 x squared. 1/9 plus 25/9 is 26/9 x plus 5/9. And so what you wind up with is the answer you're looking for, which is the coefficient of x. All right, so that's sort of, the DSATday3 is extremely helpful when it comes to properties of exponents. Okay, the one thing, let me double check, because there is one thing to keep in mind with this. If you are multiplying, two variables, or if you're multiplying a variable and then times a quantity, okay, the DSATday3 doesn't understand that 3x times x plus 1, it doesn't understand that that's multiplying. And you have to explicitly multiply. You would have to put the multiplication symbol in after a variable. So anytime after a variable, if you're multiplying a variable by something else, you have to have explicitly selected multiply. Okay? It'll give you an error message, so if we kind of look at what that would be, 3x times x plus 1 on the DSATday3. Notice it specifically says it doesn't understand implied multiplication, but if you went in and added the multiplication symbol here, again, it's just going to copy down what we have. It's not going to do anything with it, but now it does understand that you're intending it to multiply. Now, if you take a number times a variable, it understands that that's the implied multiplication, but not no multiplication after a variable is understood. Okay, the other thing too, just really quickly, since I'm talking about the DSATday3, if you did this previous problem and you got decimal answers instead of the exact fraction form. It just means you're in approximate mode. So if you look at your calculator right here, where it says, mine says auto, you can change that from this mode key. This mode key is right below the white alpha key. And if you scroll down, so a couple things that I would recommend. First thing, I would recommend that you be in float mode. The default setting is float 6, in which it only displays 6 digits. Okay? And so I would go into this and move it up. So it's, for me, it's option E. Okay? And just choose float. What float does is it shows you as many digits that fit in the display area. Okay? So that's ideal. I would also change it to degree mode unless you're working in your, with trig ratios in your classes and you're working in radians. This should be in degree mode. It'll say, I'll show it in a second, it'll have a DEG on the bottom of your screen that tells you you're in degree mode. Okay, and then if you go to the second page here, so you can either keep scrolling down or you can jump to it by hitting F2. Okay, you have this option here of either being in exact mode, which is only gives you exact answers, so like radicals or reduced fractions, or approximate mode, which only gives you decimals. For a lot of the science classes, they ask you to go to approximate mode. My recommendation is be in auto mode. And what auto mode means is it's going to display your answer in the same form that you enter it. So if we come back here, let's say for this problem, let me delete this here. And let's say you were typing this problem, okay, and you wanted it in decimals. And you can do one of two things. If you're in auto mode, you can either hit this green diamond button. Notice here this diamond displays, right? So here there's no diamond. I hit the diamond button. If this diamond is displayed, it'll give your answer in decimal form. So if you needed decimals and you're in auto mode, you can just hit diamond before you enter the problem. The other way that you could get an answer in decimals is just somewhere in your entry, put 1 decimal. If you use a decimal point somewhere in the original entry, your answer in auto mode will be displayed as a decimal. And so those would be your 2 ways. I definitely just say keep it in auto mode if you need to use approximates or decimal form. What it will do when you hit the decimal is it will give you that approximate form. All right. So let's now move to sort of the heart of the nonlinear equations, okay, and that is quadratic functions. So I want you to try this problem right here. Notice I have some information on the right. I will talk about that in just a moment, but see what you remember and how you would answer this particular question. Expand the notes here. The next slide has these other forms too, but I'm going to talk about all 3 of the forms on this slide. So quadratic functions can be represented in 3 different ways, or tend to be represented in 3 different ways. So in general form means it's just expanded completely. Okay? If you are working with general form, then the vertex can be found by taking negative b over 2a. This is the part of the quadratic formula that comes in front of the plus or minus. Okay? That's your vertex. And then if you take whatever your vertex is and you substitute that back into the original function, so notice here I'm using function notation to represent that. So take the negative b over 2a, plug it back in to the original function and evaluate, and that would be your y coordinate of the vertex. If you're in vertex form, and it's called this because vertex form is just the form that kind of uses the transformation rules of a parent function on a graph. Okay, so the h's are the horizontal shifts, k is the vertical shift, a is the compression factor, and indicates reflection. Okay, and so the vertex is just going to be the horizontal shift and the vertical shift, hk. And then finally, in intercept form, this gives you your 2 x-intercepts, p and q. Okay, and intercept form is just the function written in factored form. And if you needed to find the vertex here, it falls halfway between the 2 intercepts. So if you took p plus q and divided by 2, that's going to give you the x coordinate of your vertex. And then just like with the first one, if you evaluate the function for that number, plug it back into the original equation, everywhere there's an x, that would give you your corresponding y coordinate. Okay? So all of these allow you to find that. Now, in this particular problem here, it's asking you to find your minimum. Maximums and minimums are the vertex in a quadratic function, right? If it opens down, it's a maximum. If it opens up, it's a minimum. Okay, but either one of those is your vertex. And so if you're given this problem, it's written in general form. And so the easiest thing to do here is to probably just take negative b over 2a. All you need is the x value of your vertex. And so negative b over 2a, your b value is the coefficient of x. So negative 34, notice the two negative signs. And then 2 times your a value, which is 7. I can cancel. So the negative signs cancel. 2 goes into 34 17 times. And so I wind up with my answer of 17 over 7. Now, the other way that you can solve this is using the calculator, because the calculator graphs as well. So if I just typed this function into my calculator, I get 7x squared minus 34x plus 24. What I can do is I can just go find it, and I see my x coordinate is 2.429. And the SAT will accept rounded answers. So even though 17 over 7 is more exact, it would accept the 2.429. Okay? So you can solve it visually in that regard as well. The straight lines, okay, when they graph here, will show you the x-intercept, y-intercept, and any intersection of lines. For a quadratic function, it'll give you the x-intercepts, any y-intercepts, and then the vertex as well. And then if it is part of a system, it'll give you the intersection points. Now, just really quickly, because it will come up in a bit, when you are calling on regression equations using quadratic functions, so if you're given a set of points and you want to find the equation of that line, or of that parabola, you can use any of these forms. All of these work in the regression forms. So if you want the regression for general form, and really general form, like the only thing that really, like the main thing it gives you is the y-intercept. The y-intercept on this is the point C0. You don't need a graph to show you that. And so, I mean, pulling it out like here, it just allows you to find your A, B, and C value. And it allows you to find the y-intercept. But here you would say y1 is similar to ax1 squared plus bx1 plus c. Again, just like the linear regression, you need to use the subscript ones, and it'll pull up the a, b, and c value for you. If you type your regression as y1 is similar to a times the quantity x1 minus h squared plus k, it will do the same thing. It will pull up the value and give you the h and the k value. So using this form would allow you to find the vertex easily, even though, although you can find it on your graph. But this will give it to you in a form that you can then go in and test the fraction form of it. Okay, so if you want to enter your answer as a fraction, you could. Okay, and then the final one, if you want to find y-intercepts and you're using regression, you can say y1 is similar to a times x1 minus p times x1 minus q. And it will give you the p and the q values, which are your x-intercepts. So if you feel like you need to find the rational forms of these, you can use regression to find that. All right, so let me again just show you. So this has nothing to do with this problem, but it sets up how to use the calculator. So let's say you wanted to find the fraction form of this answer, and what you see on the graph is 2.429. If you want to confirm again that like it is, or what is that fraction form, here's what you can do. I can use regression equations on this function. Okay, if I enter my equation as a function, so f of x, what I can then do is I can create a table of values for that function. And I don't even have to look and find specific numbers. All I need to do is pick 3 values. Remember, when you use regression, you need one more set of data points than the power of your equation. So quadratic equations have a power of 2 or a second degree. So we need one more than that. We need 3 points. So if I have a function listed above, I can evaluate the point 0 and f of 0. I can enter my answer as that function notation, 1, f of 1, 2, f of 2. I don't need to give it any thought, okay, but that's going to give me 3 points. You'll see them on the graph, but it doesn't really matter because what we're trying to do is, if I want to find the vertex of this using this idea, I'm going to type in vertex form. So y1 is similar to, y1 is similar to a times the quantity x1 minus h, quantity squared, plus k. And notice it gives me my values. Now my h and my k are still written as decimals, just like what we saw here. But the nice thing is I can call them out in a later line. If I want to find what is the x-coordinate written as a fraction, I type h to represent this x-coordinate of my vertex, hit the fraction key, and notice it now confirms. 17 over 7 is the correct answer for that. But anytime you're working with these functions, if you need to know the equation in any form, just create a table of values for that function, and you can call it up. Okay. Now, just to show, again, if you wanted to find one of the other forms, y1 is similar to ax1 squared plus bx1 plus c. Notice it gives you the coefficients. It confirms these, right? 7, negative 3, 4, 34, and 24. And finally, if you wanted to find the x-intercepts, so here you can see the x-intercepts on this. They are, their numbers are, the 4 is good. You don't need the fraction form of that. But if you wanted to find what is the fraction form of this other intercept right here, you can call in y1 is similar to a times the quantity x1 minus p times x1 minus q. And that gives you p and q. These are your two x-intercepts. And so if you want to know what is the fraction form of p, call on it, hit the fraction bar, and you see that's actually 6/7. Okay, so there's a lot you can do with these regression equations if you need to. Like if you can't figure out what the other form is, you can find all of this information just by evaluating functions and calling on the correct form of that.
Could you do 42 as well?
Okay. Yeah. All right. So 42 introduces this type of question that the SAT does that's really complicated. Okay? And the reason it is because we don't ever, like I have never taught this style of problem ever in any of the classes I've taught. So that includes pre-calc. Okay? And it is, you have to use the discriminant to answer this question. Okay? So there are two types of questions that the SAT asks in this new digital form that are, obviously they're considered the hard questions. Okay? That require you to either take a system of equations that involves a quadratic function and a linear function, set them equal. Like again, you'll see examples of this. I don't remember. Don't remember if we're going to go through them, but there will be some in your practice problem. But if that's the case, and it says that they intersect at 1 point or 0 points, I'm sorry, 0 points or 2 points, or no points, they never intersect, then you can use the discriminant. So something like this. I'm going to erase all of my notes over here to the right because I wasn't going to, or I'll need to use this space. All right. So follow with me on this. Like again, it makes sense, but it's not like the most intuitive thing that you would normally do. So let me delete what I have here too. All right, so as I'm kind of doing this, if you want to take a look at this problem really quickly and try it on your own, like 42, see how you would find it. It's like give yourself an idea on that. All right, so I actually have those in the notes right here. So if you look at this set of notes, the discriminant is taking general form, ax squared plus bx plus c, the expanded form, and it's the part of the quadratic formula that's inside the square root, inside the radical, b squared minus 4ac. Now, if you remember working with quadratic formulas, if that number is 0, right, and you have negative b over 2a plus or minus 0, that means there's only one solution. So if the discriminant is equal to 0, you have only one solution. If the discriminant is a negative number, you can't take the square root of a negative, so that means there's no solutions. Okay, so those would be the two that probably show up the most. Like, more than likely, you guys will see a question like this. It'll probably be one of those two. This one is the other version, okay? And that is if the discriminant is a positive number, then you're going to have two solutions. So here's what we know about this question right here. It asks or tells us that we have a parabola with a given vertex. Let's call this h and k, right? So we know that our parabola is y equals a times x minus h, which is 9 squared, plus k, which is negative 15. So we know that this is sort of the form of our parabola. Okay, and we know that it intersects the x-axis at 2 points. What that means is when we expand this out, the b squared minus 4ac has to be greater than 0. So that's the other thing that we know. Okay, and so now it's asking you which of these could possibly be the values of a, b, and c, where all of this holds true. So let's kind of take a look at where you would go from here. And so the first thing we need to do is expand this out and write out what that expanded form is, so that we can see what our a, b, and c values are. Okay, so if I expand this out, I'm going to take my binomial square. I get x squared minus twice the product of those terms. So x times a negative 9 is negative 18x. Negative 9 squared is plus 81. I'm now going to distribute this a. Okay, so the a distributes through. And then the minus 15 carries along. Okay, so here's where this is part of the difficulty. Now, the first difficulty is even understanding how you set it up and solve it. The second difficulty is being able to wrap your head around the fact that my a value is a, my b value is negative 18a. So that a is part of the expression for b, and my c value is this whole quantity 81a minus 15. All right. So, everybody with me so far? Here's where it starts to diverge a little bit. So hopefully you can kind of. I'm trying to use different colors to indicate each thing. All right. So the next thing that we do is we're going to use these values to evaluate our discriminant. We know that the discriminant has to be positive here. Okay, and so what we're going to do is we plug in a negative 18a for b. We plug in a for a, and we plug in 81a minus 15 for c. So this is a relationship that has to exist in this problem. Okay, so if we square 18, or negative 18 and 18 squared are the same thing. So we get positive 324a squared. Here, if we distribute 4a through, so 4 times 81 gives us 324, so we get a negative 324. A times a is a squared. And then negative 4a times negative 15 gives us plus 60a. And so all of this is just a way to find that these cancel. 60a is greater than 0, so if we divide by 60. Okay, so we know that a has to be greater than 0. All right. So now is the last part of this. Okay, and that is we come back and we want to evaluate a plus b plus c. Okay. And we know that this has to equal the quantity that's inside here. And so a plus b plus c has to either equal negative 24, negative 15, negative 18, or negative 13, correct? Okay, so that's what we're looking to test right here. And so if we take our expressions again, A is A, B is negative 18A, and C is 81A minus 15. And so if we combine all of these and solve, we have A minus 18A plus 81A. So again, I'll show on here. So I have 1A minus 18A plus 81A. So I get 64A minus 15 is equal to whatever this number is. And so now if I'm solving for this, I add 15 to both sides. Does everybody see how I did that again? And now I have 64A is equal to something plus 15. And so here's what has to happen is when I divide by 64, this whole quantity right here, and one of the answer choices plus 15 divided by 64 has to be greater than 0. Right? So let's test those numbers. Okay, negative 24 plus 15. So if we put a negative 24 in here, do we get a positive A? Negative 24 plus 15 is a negative number, so no. So it's not negative 24. Again, let's test a negative 15 plus 15 over 64. Does that give us a negative? No. Or, a positive? No. Negative 18 plus 15? No. Negative 13 plus 15? Yeah. I've tried to do this easier ways. This is the way. This is the way that it shows in their solution manual. Okay? This is now this is as hard as it gets. The other problems, the ones that you would most likely see that involve this, is going to be a little bit easier. But it's based on the same concept of finding the discriminant b squared minus 4ac and either setting it equal to 0 or setting it less than 0. Again, we'll come across one of those at the end of this section. I assume that it's one that I'm going to be showing you. Let me go back, since this kind of ties into, like, if you want to see a couple things on the website or the classroom site, the Canvas page, that I want to make sure is clear to everyone. All right, so I talked about how this web page is set up, right? The left side, all of these are just digital practice tests. So these right here these mirror the ones from the College Board, from the Blue Book. If you go into the Blue Book, they have 4 practice tests for you. These right here are those same questions, but they regenerate different numbers. So if you've already done those practice questions and you want to do other versions of the same questions, that's what you can do right here. Okay? For both the Module 1 and Module 2. If you keep going down, for these, what I've done is I've sort of like selected pools of questions that fit the sort of the distribution of the different content areas. So if you want to take full practice tests that randomly mix all the different questions that I've created in my pool, this would be the place where you can do those full practice tests for Module 1 and 2. And then down here is just if you want to do extra questions from the notes. So like if you want to go in and try a question similar to 42, you can go in. And it's usually by the slide. So 41 and 42 might be like it's either one or the other. You can test those. Okay, so I don't know that I told you or talked about what was on the right side. So I showed you where the links to the College Board stuff was. But if you take the 4 tests that they gave you on the Blue Book, okay, they have those tests. These are PDF versions of those tests. So if you like needed to print something out, like and you want it, like if you're on a trip or something, you don't have internet access, you can print these out and you can do them. And it has a key with it. Okay, and I believe the last thing. Let me see. So I think that key, I'll double check it, and if it's not, I'll try to make them available. But there are solutions to these. Again, I think the key might just be the answers, but I will double check and see if I can find the solutions. If you ever have any questions on any of those too, though, please feel free to ask me. For most of these questions, I have detailed solutions that walk you through the steps as well. If you come to a question that we haven't gone over in the class. All right. So let's go ahead and move to the next slide here and try number 43 really. So just like with linear functions, one of the things that you are responsible for is being able to interpret the different forms of your quadratic functions. And so I already talked about it. The vertex represents maxes and mins. Okay, a lot of times with story problems, it's not a bad idea to scan the answer choices and see what it is that you are trying to interpret. And you can tell, since your answers are all, it's just a sentence, that you're going to be interpreting something here. So the metal ball's height is 3 when it started moving. Its minimum height occurred 3 seconds into it. The minimum height occurred 7 seconds into it, and the minimum height was 3. All right, so what you can see right here is you need to determine what the 3 and the 7 represent, right? So in this function right here, x is seconds, f of x is height. So you know that when you are looking at this, which of the following is the best interpretation of the vertex? So our vertex hk is 3, 7. And so what that means is at a 3 seconds in, the height is 7. Okay, and that's the vertex. It opens up, right? It's a positive leading coefficient, so it opens up. That means right here is 3 seconds in with a height of 7. So that's the minimum value. And so looking at this, it says the minimum height was 3 inches. That's not true. Height is here. The minimum height occurred 3 seconds into it. Is that true? Yeah, that's what it's asking for. If you want to check, the ball's minimum height occurred 7 seconds. Nope, it was 3 seconds. And the minimum height was 3. Nope, the minimum height was 7. So if you go in there by process of elimination or by like finding the one that makes sense, you can select the correct answer. All right, let's end with this question here, 45. See if you can answer this, please. All right. How many of you used quadratic regression? Okay. How many of you just tested points? All right. Here's my recommendation again. If you're comfortable with Desmos, what you can do, the way that I would look at this is all my answer choices are the expanded form and the general form. So the first thing I would do is look, 0, 13, like that's the easy one to test. All of these have the same, like 0, 13 works for every single one of these, right? So you can test points. It's a valid way to solve this. I'm going to show you 2 ways to use Desmos just because, again, it gives you like this sense of security that you got it right. So since you see 3 points here, we can create a table and just copy those points down. Okay, and now, what form are all of the answer choices? It's that general form. So when we pull up our linear regression or our quadratic regression, y1 is similar to ax1 squared plus bx1 plus c. And what we want to do is see it's a coefficient of 1, then 10, then 13. 1, 10, 13, the coefficients of option 1. So that would be my answer. Now, there's another way, if you're not comfortable with the regression, okay, there's another way that you can use these, use the features of Desmos to solve this. Okay, you could plot these points. Okay, so we could plot the point -1, 4. And you don't have to label it, but I'm going to just to indicate here. I can plot the point 0, 13, and I can plot the point 124. So just putting these in ordered pair form, I see all my points here. And then if I want to test each of these, I can just start typing these functions in. And you don't even really need the f of x. I'm going to put it there, but you don't have to have it. If you just type x squared plus 10x plus 13, x squared plus 10x plus 13, 10x, there we go. Right, and so like right here you see, right, all of those points fall on it. Happened to be the first one we tested, but if it wasn't, you could plug all the rest of them in. Here I'll show you that you don't need the 10x squared plus x plus 13. You don't need the y equals or f of x equals. X squared plus x plus 13, and finally x squared minus x plus 13. And so when you look at all of these, the only one that fits all of them is this blue one. That's option 1.